Hello, and welcome back to Have You Ever Wondered? Today, we're diving deep into the fascinating world of steel manufacturing. We'll uncover how H&I steel profiles and the ubiquitous rebar are made. These materials are the backbone of modern construction. Let's start with the basics. What are H&I profiles? They are structural steel beams named for their cross-sectional shapes. H-beams have wider flanges than I-beams, giving them greater strength and rigidity, especially against bending. I-beams, also known as universal beams, are lighter but still incredibly strong. Both are crucial for supporting heavy loads. Rebar, short for reinforcing bar, is another essential steel product. It's typically made from carbon steel and reinforces concrete structures. Concrete is strong under compression but weak under tension. Rebar provides the necessary tensile strength, preventing cracks. The journey for all these steel products begins with raw materials, primarily iron ore, coke, and limestone. Iron ore is mined from the earth. Coke, a fuel made from coal, acts as a reducing agent and provides heat. Limestone helps remove impurities. These materials are transported to a steel mill, often a massive complex. The first major step is the blast furnace. Here, iron ore, coke, and limestone are fed into the top of the towering furnace. Hot air is blasted into the bottom. The coke burns, generating intense heat and carbon monoxide. This reacts with iron oxides, reducing them to molten iron, also known as hot metal or pig iron. The limestone reacts with impurities, forming a slag that floats on top of the molten iron and can be easily separated. This pig iron is rich in carbon and contains other impurities, making it brittle. To transform it into steel, it undergoes refining. The most common method is the basic oxygen furnace, or BUF. A lance is lowered, and pure oxygen is blown onto the molten metal. This oxygen reacts with carbon and impurities, oxidizing them and forming gases or slag. This rapidly converts pig iron into steel. Another method, especially for recycling scrap steel, is the electric arc furnace, or EAF. In an EAF, large graphite electrodes are lowered into a furnace filled with scrap steel. A powerful electric current creates an arc. This generates immense heat, melting the scrap. EAFs are highly efficient and environmentally friendly, using recycled materials. Once the steel is refined, it's transferred to a ladle and often undergoes secondary metallurgy processes. This involves further refining to achieve precise chemical compositions, remove remaining impurities, and adjust temperature. Alloying elements like manganese, silicon, nickel, and chromium can be added to give the steel specific properties. Now, let's focus on how this molten steel is shaped into H&I profiles and rebar. The first step is continuous casting. The molten steel is poured from the ladle into a tundish, which then feeds it into a water-cooled mold. As the steel passes through the mold, its outer shell solidifies. Below, water sprays cool the strand further. Guide rolls support it as it fully solidifies into a continuous slab, bloom, or billet, depending on the desired final product. For H&I profiles, blooms are typically cast. For rebar, billets are used. After continuous casting, the solid steel sections are reheated in a reheating furnace to become malleable. For H&I profiles, the reheated blooms are then sent to a rolling mill. This mill consists of a series of stands. The steel passes through these rollers repeatedly, undergoing immense pressure. The rollers are precisely shaped. Each pass brings it closer to the final dimensions. This hot rolling process is highly precise. After rolling, the profiles are cut to length, cooled, and then straightened. For rebar, the reheated billets go through a similar hot rolling process, but the rollers create a round bar with deformations. These deformations are crucial for the rebar to bond effectively with concrete. After rolling, the rebar is cut and bundled. Some rebar might also undergo quenching and self-tempering or thermomechanical treatment to enhance its strength. Quality control is paramount at every stage of steel production. Samples are taken and analyzed for chemical composition, mechanical properties like tensile strength and yield strength, and dimensional accuracy are checked. Non-destructive testing methods, such as ultrasonic testing, are also used to detect any internal flaws. This rigorous testing ensures that the steel products meet international standards and are safe for their intended applications. Finally, the finished H&I profiles and rebar are transported to construction sites, where they become integral components. From the towering skyscrapers that define our cityscapes to the bridges that connect communities, these steel products are fundamental. And there you have it, the incredible journey of H&I steel profiles and rebar, from raw materials to the essential building blocks of our world. We hope you enjoyed this deep dive into industrial manufacturing. Don't forget to like this video, subscribe to Have You Ever Wondered?